Hello, and this time I'm talking about the addition identities in trigonometry, and here they are written out. There are ways that you can get this from geometry. I'm not going to go through all of that. I'm just going to concentrate on how you use them, and I've got a few examples to go through. But first of all, what are they? Well, if you ever have sine, cos, or tan of two different values added together, you can split this into these different forms. So sine of two things added together becomes sine of one times the cos of the other plus cos of the first times sine of the other. Okay, so you just have it either way around. And if there's a minus in between these two instead, you just put a minus here. Cos is almost the same, it's just a couple of differences. Cos, if it's a plus, you actually get a minus, and instead of being sine cos sine cos or cos sine, it's both coses. So it's like cos of the first times cos of the second minus sine of the first sine of the second. And when there's a minus sign in it, you get a plus there. Tan is different again, quite strange. So tan, if it's add, then you get tan of A plus tan of B, all divided by 1 minus tan of one times the other. And if it is a minus sign in there, then you just swap the signs over again. So that plus becomes a minus, and that minus becomes a plus. Now, often what you see is you see them written out like this, plus or minus, plus or minus, plus or minus, and then in order to get it the right way around, you can switch that round. So here, it's plus minus and plus minus, because the plus goes with the plus and the minus goes with the minus. But here, the plus goes with the minus and the minus goes with the plus. So you write the plus minus sign here and the minus plus sign there. And here, a plus goes with a plus and a minus, and then a minus goes with a minus and a plus. So again, you sort of have them the right way round, so that the top goes with the top goes with the top, and the bottom goes with the bottom goes with the bottom. So if you see them just written out once like that with the double signs, just tops goes with tops and bottoms goes with bottoms, and just be careful to read those off in the right way. Okay, so that's what they are, that's what these addition trig identities do, and then how do we use them? Well, you might be asked just to work out some values, and you might be asked to muck about with some trig to sort of turn it into something else. And we'll go through both of those kind of things today, and then some other videos will sort of look at that in more detail, sort of generally with double angle identities and things like this. But anyway, let's just concentrate on this video for now. So looking at this example, cos A is minus 4 over 5, and A is an obtuse angle in radians. So if we draw a little diagram, we've got A coming over here somewhere, and it feels like, because it's sort of given as a fraction, we should be able to make sort of a triangle. But I think what we need is we need to turn this into this acute angle, because if it's in the first quadrant, we can kind of deal with that a bit better. So I don't know what we want to call this. Maybe we want to call it B. So this is not sort of A and B up here. This is just so we can sort of see these two different angles at work here. Okay, so in this situation, we've got sine of A, and whatever B is, we know that B is pi minus A. Yeah, because pi is the same as 180 degrees, and take away the A, we get the B. And what we're saying here is, okay, well, let's work out what sine for that B value is. That's quite straightforward. That's the same as if it was over here. And if it was over here in the first quadrant and it was a nice triangle like this, we know that that would be 4. That's the adjacent, that's the hypotenuse, and it's a 3, 4, 5 triangle. So we know that sine of B is going to be opposite over hypotenuse. And because it's sine and sine is positive in both of these things, then these two are going to give the same answer. So we can just say that sine of A is the same as sine of B and is also 3/5. So we didn't actually need to use our addition formula there, but I suspect we will need to for part B onwards. So looking at part B, we have cos, and we've got two things added together. So let's use the addition formula for this, and we can say that this one is cos of the first thing times cos of the second minus sine of the first thing times sine of the second. Well, let's just stop and think about this for a second. We know what cos pi is, and we know what sine pi is. Okay, cos pi, it starts up here and does this, and pi is halfway through, so cos pi is minus 1, sorry. So minus 1 of cos A, and sine pi, well, if we draw out sine, then halfway through is pi, and that's actually 0. And 0 times whatever this is will always just give us 0. So the answer is just this. Okay, we don't need the 1, minus cos of A. So if that's true, then we know what that is. I'm going to have to delete this so I've got space to do the other questions. If we know it's minus the cos of A, we know that cos A is that, so minus it, it's going to lose that, it's going to be 4/5. So that one's nice and straightforward. Okay, so let's look at part C. I imagine this is going to be the same because we've got two things added together. We're just going to use the addition formula. So we've got sine of the first, but this time cos of the second, plus cos of the first times sine of the second. Sine of the second, which is A, yeah. Trying to confuse myself. And we know what sine pi over 3 is, okay, because if this is pi, then we can split that into 3, so this is equivalent to 60 degrees. And we know that sine of 60 is root 3 over 2, so this is going to equal root 3 over 2 cos A, and cos of 60 is a half, so plus 1/2 sine A. We can't simplify it down anymore, but we don't really need to because we can just replace the cos A and the sine A. We know that cos A from the question is minus 4/5, so put a 4 on that, and times that by 5, we'll get 10. We can actually cancel that down, can't we? It's going to be 2/5, really. And sine of A, we've already said, is 3/5. So again, we can replace that times by 3/5. It's 3, and 2 times 5 is 10. I suppose because they're both over 10, we could simplify that even more. Let's so we won't cancel that down after all, and we could rewrite that as 4 root 3 plus 3 all over 10. Okay, and there we go. Nice absolute answer using that addition formula. Wait, I've just noticed I missed my minus sign. I had a minus sign there, so I need to put my minus sign there. That was close. I would have lost marks in an exam for that. Hopefully they'd have seen it here. I'd have got all my method marks, but got to make sure you don't lose those minus signs for that final answer. Okay, I'm going to have to get rid of this so that I've got a bit of space for tan. I suspect this is going to need a bit of writing out, so obliterate that, I'm afraid. And this time we've got tan. Okay, well, we can do that as well from up here. We can say that tan of B is, because remember we're sort of over here, look at this, tan of B is 3/4, and ASTC, so this gives us a negative answer, whereas, of B is going to give us a positive value, but we're supposed to be over here, it's supposed to be negative. So tan of A is going to be minus 3/4, okay, because A is in the second quadrant, and that is a quadrant where tan should be negative. So we know what tan of A is, that's quite helpful, and we can do the exact same expansion as before. So it's up here, so it's going to be tan of the first plus tan of the second, no, not B, from the bracket is this A, so we've got to be careful now. Oh no, that A is that A, yeah, no, we're okay, we're alright. I was getting confused with my B's, because that B from here is not that B. I should have used a different letter. But anyway, I don't need it, because that's A, and that is the A. And this is all divided by 1 minus tan of the first times tan of the second. Okay, well, we can work this out. Tan of pi over 4, well, pi over 4, if that's pi, is 45 degrees, yes, cutting into 1, 2, 3, 4, and tan of 45, we know that that's 1, so we can rub all that out, and we can just get rid of that because that's 1 time. So 1 plus tan of A and 1 minus tan of A. And we know that tan A is minus 3/4. So this is 1, should be plus, but because it's negative, minus 3/4. And this is 1 minus a minus number, so it's plus 3/4 because the minuses cancel. So let's have a look. What's that give us? That gives us 1/4 over, so just split this into 2 questions. This is 1/4 over 7/4, and if we keep change flip, we're going to get 1/4 times 4 over 7. They cancel, and we're going to get the answer of 1/7 in the end. Okay, so that got a bit messy with all the drawing on the screen, but hopefully you can see that it's just a case of look up or remember what these are, plug the values in, and if you do know the exact value, because they're sort of nice fractions of pi, then you just pop them in and carry on. And it's just that I found this bit the trickiest, having to be that obtuse angle and then working out this amount and then translating it back in from the first quadrant. That's B, so it's the same as this. So that was doing the triangle like this, with all positive numbers was giving me the first quadrant, and then for sine it was the same because they're both positive, but for tan and for cos it comes out with the negative value, which is why it's negative there and negative for tan. So just that I thought was the hardest bit. Everything else was just substituting and solving. Okay, so it's getting to be a bit of a long video, I'm afraid, but we'll have a look at 2 more examples. Given that cos y is sine of x plus y, show that tan y is sec x minus tan x. Now that's instantly makes me feel quite worried. This feels like it's going to be a difficult question, but I'm not gonna worry about this bit for now. We're going to come back to that. It's a show that, so when we're a bit further along, we'll try and then aim at that. But let's just start with this thing here. Cos y, we're going to leave that. Sine, well, it's an addition angle, addition identity, I mean. So we can just replace that. So let's see what happens. Cos y is sine of x times cos of y plus cos of x times sine of y. Okay, so that's a good start, and now I'm already thinking that we've got a cos y there and a cos y here, and we want to get tan of y. So, interesting. How are we going to do that? Well, if this was divided by sine x, then that would certainly give us upside down tan. So I don't know if that's useful, but then we would have to have all of this divided by sine. Sorry, not sine of x, sine of y. We'd have to divide that by sine of y. Now that doesn't give us exactly what we want, because that gives us upside down tan, but that's, you know, better than nothing. But then it doesn't separate out very nicely. So well, let's have a look what we get anyway. So we get cot x equals, well, if we try and split this, we're going to have sine x and then cot x plus, now this one's nice because this is going to just cancel these, and we're just going to get cos of x. So that is quite nice. But now I'm going to struggle to turn this upside down. If I want to turn this upside down, that's not going to work because I'd end up with 1 over all of this equals tan. And whereas that's nice, I've got the tan x, it doesn't give me this very nicely. So I'm going to abandon that one. It might be that I should have persevered, but I just get the feeling that's not quite where I want to go with that. So the other option, of course, is that we make a tan somewhere else, and then it gets rearranged. So that's entirely possible. So if we think about this one, this is sine y. If we want tan y, we need sine y over cos y. So why don't we just divide everything by cos y? So cos y divided by cos y is 1. Sine x is just going to be sine x, that's not going to be affected. Cos y divided by cos y is 1, so we'll just leave that as sine x. plus cos x sine y. Well, again, the cos x is just going to stay there, and then sine y divided by cos y is the tan y, which is what we wanted. Okay, well, this looks good. Slight problem is that we've got this cos x on our tan y, and there's no cos x here. So let's just divide that through, and this seems plausible because, look, we need a tan x as well, and that's going to give us a sine x over cos x. So let's just divide through by the cos x. We're going to get 1 over cos x here. Sine x over cos x is tan x plus tan y. Well, this is looking rather good, actually, because 1 over cos is sec. So we can say tan y equals 1 over cos is the sec that... Whoops. That's the next video. Tan y is 1 over cos, which is sec of x, and then it should be on the tan side, so if we move that over, it becomes minus tan x, and that's exactly what we wanted. So we got there in the end. Now, what I'd say is, you know, exactly like it happened to me, you've got to look at something, have an idea, and try it. And if it starts to get a bit grotty, like, well, you've got to have the experience of having done loads of questions where you think, yeah, no, this is not going in a helpful way. I'm going to abandon this one and try something else. And then spotting things like that sine y could become the tan y and things like that. You just got to try stuff, and when it starts to look reasonable, you know, persevere with it. And if it's starting to get really, really grotty, then there's a chance that you've gone down the wrong way. You might want to explore something else. But if that hadn't worked, we'd have perhaps gone back to the first idea and tried to push through some of the tricky rearrangements. So that would be my advice. You just got to try stuff and see what happens. And hopefully do enough practice before an exam that when it comes to the real thing, you've got that experience to sort of mean your first guess is a good guess. Okay, and the last example, write sine of x plus pi over 6 in the form of p sine x plus q cos x, where p and q are constants to be found. Okay, well, this presumably is going to be from our addition identities, so let's just write it out. Sine of the first times cos of the second plus, because it's a plus cos of the first times sine of the second. Okay, well, that looks good. And of course, pi over 6, well, we know what that is. Pi over 6, if that's pi coming around to there, then pi over 6 is going to be 30, no, that's a 6, 30 degrees. And we know what these things are, so we know that sine of 30 degrees is going to be a half, so that's going to be plus a half, cos x. And this one is cos of 30, which I believe is root 3 over 2 of sine x. So actually that was really straightforward because all we had to do is do the addition rule and then work out those exact values, and it's turned nice into root 3 over 2 is p and a half is q, and that's absolutely fine. Appreciate that's been a bit of a long video. Well done if you're still listening, if you managed to get all the way through. If you have any questions, then pop them down in the comments, but I think we'll leave it there. Next time, as you saw, I'll be talking about double angle rules. Such fun. Bye!